Hello everyone, my name is Arun and welcome to my channel. This series is a tutorials on C programming, and in this tutorial we'll be writing a simple program to calculate the length of a point, distance between a point and an origin. Okay, and also we'll be calculating the angles made by the line joining the origin and the given point about the x-axis, and the quadrant are on the axis on which the point is actually located with. And this program acts as a good exercise to look at our if else if and else construct, and also at the same time while explaining this else if and else construct, we'll be coming across multiple conditions, and to explain and use them we're going to use the relational operators and the logical operators in this program. Okay, hope you understood this. Okay, now let's walk into the program. I already have the program written over here. I'm just going to walk you through. In these two lines we just include the stdio.h and a mathematics library. Okay, and now I start my main program over here. Okay, and now get the we need variables to get the coordinates, x and y coordinates of the given point, the length and the angle. So I'm writing with the double keyword. I'm creating four variables x, y, l and a. Okay, and next what I'm going to do is I'm just going to ask the user to enter the coordinates x and y of the given point. Okay, I'm printing a message so that the user knows what to do, and I'm getting the value from the user using the scanner function. And now the length from origin of the given point, that is, if you connect this point to the origin and if you want to find the length connecting length, then you can use this function over here. You can write this way. Since there's a point is actually the origin, the second point that we're going to consider here is the origin. The reference point is the origin. If I use the distance formula, if I just multiply x with x itself and y with itself, and then add these two sums and take the square root of it, this will give me the length. Okay, of the distance between the point and the origin. Okay, I can write like this. Instead, I just want to introduce you all to a power function over here. This power function, okay, what it does is that it just calculates the exponent a power of a particular value. Suppose if I want to calculate the power of if I want to calculate x raised to the power 2.5, okay, I just have to write power x comma 2.5. That is equivalent to writing it as x power 2.5. And you cannot write this in C with this symbol, because this symbol, the caret symbol, is actually used for bitwise operations, so that is not available for power, so you cannot use this. Okay, so we have to use this function. Okay, we can write it like this, but this is for in generic you can use this. Okay, this is the power function. And now what we are going to do is we're just going to calculate the angle. Okay, now the angle is actually in degrees with respect to the x and the angle is measured with respect to the x-axis. If the magnitude of the angle is positive and it's anti-clockwise, okay, the magnitude of not the magnitude. If the sign of the angle we come across is positive, then it's measured from the anti-clockwise sense. If it is negative, it means we are going in the clockwise direction. Okay, and the angles are measured with reference to the x-axis. So keep that in mind. Okay, now to measure the angle, we'll come across these statements later. First thing is this: if suppose the angle is measured by using the tan inverse function, the arctan function available in the mathematics library, and to calculate calculate the arctan, we need to calculate this term y divided by x. Okay, we need to calculate this term y divided by x. And now here a problem can crop up when x is equal to 0. Okay, when x equal to 0, that means that we are lying on the y-axis. Okay, so we just have to tell the user that hey, you just have to make sure that x should not be equal to 0. Okay, and that's why we write all these loops over here. Write all the decision making statements over here. If x is actually 0, that means the point y is actually lying on, and y is not equal to 0, that means that the point is actually lying on the y-axis. So if you look at it in the clockwise and anti-clockwise sense, anti-clockwise sense from the if y is positive, the angle will be 90 degrees, and if y is negative, it is again 90 degrees from the negative x-axis part of it. So I am setting the angle to be minus 90. Another case, if suppose if the user wants to be really picky and says that the point is actually 0, 0, okay, and that is actually the origin. The angle between the origin and the origin is 0 itself, so we put the angle to be 0. For all other cases where x and y are not equal to 0, x and y are not equal to 0, and there is a stable angle, let's say, stable value, let's say, we calculate the angle using this function, a tan y divided by x. Okay, this will give me the angle in radians. So if I want the angle to be in some easy to visualize format, let's say degrees, I multiply this by 180 and divide that by pi. And now this variable over here, pi, m underscore pi, this is actually the equivalent of the variable pi that we use. Okay, and this is defined in the math.h file. Okay, we can use it directly in this way. Now you can write your own definition of pi, okay, if you want, or you can write 3.1415 and all to certain digits. You can proceed with it, but for a good practice, it is recommended to use this m underscore pi. The reason, because this is defined accurately for 15 to 16 digits, so that will be more than sufficient. Okay, that it will avoid any arithmetic error, or I mean not the arithmetic error. This will avoid you trouble. And now in these two statements, we print the length. We print the length of the given point from the origin, and we also print the angle made by the point in degrees with the x-axis. Okay, and now the only thing that is remaining is to indicate where the point is lying. So this is the pseudo code, or the intuitive code we can write to explain our logic. If x is positive and y is positive, the point is in quadrant 1. Okay. Likewise, if x is negative and y is positive, it's in quadrant 2. Likewise, so on and so forth. We can write the condition for the point in quadrant 3, quadrant 4. If the point lying on negative y-axis, positive y-axis, negative x-axis, and positive x-axis, like this. Okay. Now pay attention to these statements over here. X is positive and y is positive. To denote y is positive, we can use the option y greater than 0, and that is why we wrote x greater than 0. That's why we wrote x greater than 0 over here. And to indicate that y is greater than 0, we write y greater than 0 over here. Okay, and this and the option over here, what this means is that this condition and at the same time this condition, both these conditions have to be true. To make that happen, we write this and two ands over here. This actually stands for the logical and. What this does is that it makes sure that all the expressions over here, all these expressions are true. Only then it will return true and make sure that the statements below it are actually working. So that's how it is. In all these cases, we use the AND statement to make sure that our point is heard. Okay. And if I say x double equal to 0, it means that it will check if x is actually equal to 0. Okay, and it will work like that. So this is the entire logic over here. So we'll see if the points are lying in any one of the quadrants. Then if they are not, then obviously it means that the points are lying in any one of the axes. If the points are not lying on the axis itself, then the only possible way is that the point is actually lying in the origin. And then these are the relational operators that we use in our program. This is for double equal to, this is for actually comparison. Okay, for particular given variable or a value is equal to another value, something like that. And these two are for the greater than or less than operations, greater than and the less than operation, and these are for greater than or equal to and less than or equal to operations. And if you want to see if a particular variable is not equal to another variable, we use the ampersand and equal to, just like how we used that over here. And then we print them up. And just a reminder, double AND means logical and double pipe means logical OR. If you put a double pipe between two expressions, if either one of the expression is true, okay, then automatically doesn't matter what the other expression is, either one of them is true, and obviously it'll start going to do all the execution. So that's the usage of double equal to. And double equal this, not double equal to, double pipe symbol. And this double pipe symbol is towards the left of your backspace key, and also in some keyboards it's just above the enter key. So have a look at that. And now let's run this code. Okay, I've already written a shell script over here to run this code. Okay, if you followed my previous tutorial, this would be easy. And now what I can do is I can either go to the terminal and run this, or else other hand what I can do is I can just make sure this shell file is active and then click execute. And that will be better, because if I do that, I can get a detached terminal over here. I'll get a detached terminal over here instead of a small terminal from the here, and this is easy. And now I just have to enter the point 3, 4, let's say 3, 5, and point 3, 5 is actually lying in the origin, lying in the first quadrant, and that's why it says the point 3, 5 is actually the length of the point is actually 5.83095, and the angle it makes with the x-axis is in anti-clockwise direction 59.0362 degrees, and the point is in quadrant 1. And now let's test this for a tricky case like origin 0, 0, and our program does well. It says the length of the point 0, 0 from the origin is 0, the angle in degrees is 0, the point 0, 0 is the origin, and it worked out pretty well. Likewise, you can do all the permutations and commutations for all the coordinates, like -3, -4 is clearly in the third quadrant. Okay, and it will work out fine. And the angle is actually 53.1301 degrees, and this is measured from the this is actually measured from the x-axis. Negative x-axis. The angle is measured from the negative x-axis, so in the anti-clockwise sense, so we get the angle like this. And this will work for all the points. Okay, all you have to do is just enter all the points and work it out. Let's look at a point that is exactly lying on the y-axis, negative y-axis, and we get it perfectly. You can try this for other values and see it for yourself. And in this example, we wrote a small program, but we also looked in deeper and understood how to write a nested if else statement, a nested if else construct. Okay, and in these cases, since there is only one statement to execute, I can write this without the curly brackets. If there is more than one statement, then you have to use the curly brackets to get them working. And then we also saw the relational operators and logical operators. There's actually one more logical operator available over here, and that is actually the not operator, and we'll see about that in the future. And with that being said, that's all I have for you all in this tutorial. Thank you all for watching, and I'll see you all next time in another interesting video. Till then, take care.